morning all. Welcome to lecture 7 of module 1 in database management system. So today we are going to discuss on the topics data independence and also about the database architecture. So first we can see what is data independence. So in the last session we have already discussed about the 3 schema architecture. This is the 3 schema architecture. We have said that it is being divided into 3 different levels: internal level, conceptual level and external level, and each of these levels are implemented using certain schema. Internal level is implemented using internal schema, conceptual level using conceptual schema, external level using external schema or external view. Okay. So data independence is a concept that we can change a particular schema without changing the schema at the next higher level. Which means that if we want, we can change the internal schema without making any modification the conceptual schema. Similarly, we can modify the conceptual schema without modifying the external schema. Okay, so that is called data independence. Clear? This is a very important concept. So the definition for the data independence is as follows. The data independence is the capacity to change the schema at one level of a database system without having to change the schema at the next higher level. Okay. So we can change a schema at one level without having to change the schema at the next higher level. Clear? So this is called data independence. So there are two types of data independence. First one is logical data independence and the physical data independence. So what is logical data independence and what is physical data independence? That we can discuss in the coming slides. Logical data independence. So logical data independence means we can change the conceptual schema without making any modification in the external schema or the external view. That is the concept. Okay. The capacity to change the conceptual schema. Okay, we are changing the conceptual schema without having to change the external schema, without having to change the external schema or the application program. So external schema actually comprise of application or various graphical user interface programs. Okay. So that is what it is saying. The capacity to change the conceptual schema without changing the modification, without making any modification in the external schema. For example, we are adding a new table or a new row, new column in a table. Okay. So, so that is the modification, the conceptual schema. Okay. So we don't have any, we don't have to make any change in the external view, external schema, because the same modification will be displayed in the application program as well. Okay. So it refers to the immunity. This is another point. Refers to the immunity of external schemas to the changes made in the conceptual schema. Okay. So the external schema is actually immune to whatever changes that made in the conceptual schema. Okay. Whatever changes it is made in the conceptual schema, the external schema is immune to those changes. Okay. This is another point it is giving. Refers to the immunity of the external schema to the changes made in the conceptual schema. Okay, if the whatever changes is made in the conceptual schema, the external schema is immune to those changes. Okay, so let us see an example. So here we originally we had the schema where we had a table, we had a relation called a student. In that we are having 3 attributes: roll number, name, marks. Okay, so in the external view, external schema, they have displayed, the application program had displayed the table or displayed the table in this form. Okay, roll number, name, marks. Later they have decided to, the organization has decided to modify the schema. They have decided to add one more column. See, they have added one more column called a date of birth. Okay, and they are trying to insert values. So those changes will be definitely reflecting in the external schema as well also. Okay, the external schema does not need any further modification, the automatically that changes will be displayed in the external schema. See, here we had only 3 columns. Here we are having 4 columns. Okay, date of birth is added and the values also displayed. Clear? So this is called external schema. External schema. This is conceptual schema. Okay. So whatever changes that is made in the conceptual schema is being reflected in the external schema. Okay. So this is the explanation for this example. We may change the conceptual schema to expand the database by expand the database means by adding a record type or data item. We can add a record. Additionally, we can add record, or we can insert a new data item, or to reduce the database by removing a record. We also can remove one data item or a record. Okay. After the conceptual schema undergoes a logical reorganization, application programs that reference the external schema constructs must work as before. Okay, so whatever changes that we are making in the conceptual schema or any logical reorganization is taking place, the application programs that is working in the external schema will make the constructs or make the modifications. Make the required modifications. Okay, that is what it is saying. Clear? So you can very well draw this figure and make this explanation using this concept, using this table. Okay, so this is called logical data independence. Okay, so logical data independence, we have covered logical data independence. Next is physical data independence. Second one is physical data independence. So it is a capacity to change the internal schema without having to change the conceptual schema. Okay, that is, we are changing the internal schema. Okay, we are changing the internal schema without any modification in the conceptual schema. Okay, we are changing what do you mean by internal schema? Internal schema contains it is actually dealing with the reorganization of the internal storage structure or the access mechanisms. We have already seen that. Okay, if you are making such modification in the internal storage structure or access mechanisms, that modifications will not affect the conceptual schema. Okay, clear? So there will be no change required in the conceptual schema. It will automatically immune to those changes. Okay. So it refers to the immunity of the conceptual schema to the changes of the internal schema. Okay, to the immunity of the conceptual schema to the changes made in the internal schema. So whatever changes it is making in the internal schema, it will be immune to those changes. Conceptual schema will be immune to those changes. Okay, that is what it is saying. So let us give an example. For example, by creating additional access structures to improve the performance of the retrieval or update. Okay, so in the internal schema, we are modifying the access structure or access mechanism, or we are modifying the index mechanism to improve the performance of the retrieval or update. If the same data as before remains in the database, we should not have to change the conceptual schema. We are not making any change in the data. Okay, so the same conceptual schema can prevail, or there is no change required in the conceptual schema. Okay, so this is what they are saying. Modified an access structure. We are trying to modifying an access structure or storage structure. Okay, in that case, no change is required in the conceptual schema. Clear? Is it clear? So this is called physical data independence. Okay, so data independence is being classified under logical data independence and physical data independence. So logical data independence means we are changing the conceptual schema without making any modification in the external schema. Physical data independence means we are changing the internal schema without making any modification in the conceptual schema. Clear? So this is called logical data independence and physical data independence. Clear? Next very important topic we are going to discuss is the database architecture. Okay, database architectures are actually, database is having different types of architectures. Okay, so how a data structure or database can be implemented using these architectures. Okay, so DBMS architectures are of different types. First one is centralized DBMS architecture, basic client server architecture, 2-tier client-server architecture, 3-tier and n-tier architectures. Okay, so centralized DBMS, basic client-server architecture, 2-tier and 3-tier and n-tier architectures. Okay, so these all these architectures we have to study in detail. First, we can go through the centralized DBMS architecture. So before going into the theoretical part, we can just see the figure. So this is the centralized database system. So here we have a centralized database, and the centralized database is stored in a single location. So this centralized database may be a mainframe computer. Okay, it will be a server computer, a mainframe computer, which can have their own processing, which can run their own applications and so on. And they can perform every type of DBMS functionalities, execution, query processing, everything can be done in the centralized database. So this centralized database can be accessed by many terminals or many systems. So say take an example of a company or a financial company. So financial company is having a centralized database, and this financial company is having various departments like finance, purchasing, HR, sales. So all these departments will be accessing the single database. Okay, each department will not be having separate databases. They all are having a single database, and all the departments will be accessing this single database. Okay, the similar way of our campus management system. Campus management system is having a centralized database. Okay, so each student, HOD, principal, administrative officers, everyone will be accessing the same database. Okay, so this is called centralized database, centralized DBMS architecture. This is the basic figure of a centralized DBMS architecture. Okay, so all DBMS functionality, application programs, execution and user interface processing were carried out on one machine. So this single machine will be carrying all these processing, all these DBMS functionalities, application program execution. Okay, so DBMS functionality means accessing the information. For accessing the informations and all, we have to run certain application programs. So those application program will be installed in that centralized database. Okay, and user interface processing. Okay, user interface processing means for the required data need to be transferred to the user. Okay, for transferring to the user, it must be in the format of the user's perspective. Okay, it must be in the format of the user's user interface. Okay, so it has to be converted into a particular user interface. That is also done here. So centralized database is actually a computer. This is a computer. It will be a mainframe computer. Okay, or a large server. Server means only a computer itself. So this computer can process all those information. So all the application programs related to DBMS and everything will be stored in that machine. Okay, interface processing are carried out in one machine. A centralized database is stored at a single location, such as a mainframe computer. It is stored in a single location. It is maintained and modified from that location only, and usually accessed using an internet connection such as LAN or WAN. Okay, so all the data all the person who required the data from this database must access this centralized database, and they are connected to this centralized database through LAN or any network. Okay, interconnection network such as LAN or WAN. Okay, in the case of if we are having a campus management software in our college, we'll be using LAN to access those database. Okay, clear? So the centralized database is used by organizations such as college, companies, banks, etc. Okay, so all these organizations are using such centralized database system. Okay, clear? So this is called a centralized database system. The figure that is given in the prescribed text is this one. Okay, you can study or you can also go through this one. So here this thing is our centralized database. Okay, so it contains a system only. It is a system only. It is contain various application programs display control, text editors, DBMS, compilers, all type of softwares are there. Also hardware is also there. Okay, CPU, controller, memory, disk, input output device, everything. Okay, so this centralized database is a combination of softwares, many softwares and hardware. Okay, so this centralized database is connected to various display terminals. Okay, so display terminals using the network. Okay, so this is much more a sophisticated figure of this one. Okay, this is a simple figure. Much more complicated figure is this. It is showing the details of centralized database. It is containing various types of softwares, also hardwares, and this system is connected to various display terminals or systems. Okay, so this is called a centralized database system, centralized DBMS architecture. Okay, centralized DBMS architecture. Next is basic client server architecture. Let us see what basic client server architecture. So here the concept is to define specialized server with the specific functionalities. Okay, this is the main concept which is implemented here. Let us see a figure. So this is the two-tier basic client server architecture. Okay, basic client server architecture. So here the clients are the users. The clients are the users or the systems. They are individual systems. So so these individual systems can access various. We are having various specialized servers for some special functionalities. Suppose the client want to access certain files, he can go to file server. Suppose he want to access a database, he can go to a DBMS server. Suppose he want to access a web content, so he can go to web server. Okay, suppose he want to access the printing network, he can go to the print server, he can access the print server. Okay, so for specialized servers, for specialized applications or specialized functionalities, they are using different servers. Okay, or different servers are they are using different servers. So each of these client, according to their functionality, can access those servers. This is the concept of basic client server architecture. Okay, so these are the clients and these are the different servers. Okay, so in client server architecture, they are not only having DBMS server, they are having different servers, file servers, web servers, print servers, and so on. Clear? So this is the concept of client server, basic client server architecture. Okay, so it is actually implemented to deal with the large computing environments. Okay, in large computing, if we require large computing processing or computing environment, we use this concept, because this system is having all the things. We are having clients. If you want to access a file, you can go to file server. If you want to print something, you can go to print server. Okay, if you want to view email some details, you can go to email server. So all these are connected through networks. So the clients as well as all these servers are connected through the network. Okay, so let us see the description. The client server architecture was developed to deal with the computing environment. See, computing environment is actually developed to deal with the computing environment in which large number of PCs, workstations. So how they are implemented? They are implemented by connecting large number of PCs, workstations, file servers, printers, database servers, web servers, email servers, and other software equipments are connected through network. So this large computing environment is created like this. They are connecting all these PCs, workstations, file servers, all the clients and all the servers are connected through communication network. So why we are doing it? The idea is to define specialized servers with the specific functionalities. Okay, we are specifying we are dedicating a special server for a particular functionality. For a particular functionality, we are dedicating a particular server. For printing purpose, we are using print server. For accessing or maintaining a file, we are using file server. If you want to access a database, you will be using database server and so on. Okay. The resources provided by the specialized servers can be accessed by many client machines. So these specialized servers can be accessed by many clients. Okay. This is a file server is not meant for a particular kind. It can be accessed by any clients that is connected to that particular network. Okay, that is what they say. The resources provided or the data or the resources provided by these specialized servers can be accessed by many clients. The file server maintains the files of the client machine. Okay, we are giving an example of such specialized servers. File server. What is the use of file server? We are maintaining the files of the clients in the client machine. Okay, all the client's files are stored in the file server. Okay, printer server, it is connected to various printers. Okay, if we require any printing work or printing requirement, we can connect to the printer server. Okay, the client machine provides the user with the appropriate interface to utilize these servers. Okay, the client machine is having this user interface. Okay, actually this client machine is having the user interface to connect with these servers. Okay, so this client machine will be having the appropriate application program that provide the user interface, and these user interface as well as the required software to connect with this DBMS server or connect with these servers, specialized servers. Okay, so for to make the connections possible, we will be requiring certain additional softwares and all. Okay, that will be provided by the client along with the interface. Okay, so this is called a basic client server architecture. Some more point is there. A client is typically a user machine that provides user interface capabilities and local processing. Okay, so who is a client? Client is a user machine. Okay, client is a user machine which provides user interfaces and other local processing. Local processing is done here. Okay, if the client want to access a DBMS server, okay, that message will be accepted by this client machine, and it will do the basic processing, and that request will be transferred to the DBMS server. Okay, so local processing will be done here. For that, it is having certain specialized softwares. Okay, when a client requires access to additional functionalities such as database access that does not exist at that machine, it connects to the server that provided the needed functionality. So when if this client want to access a particular database, okay, so this client is not having a does not having any database. Okay, so what does this client do? The client will make the processing, and it will connect to this DBMS server and make the processing. Okay, a server is a system containing both hardware and software that can provide the services to the client. So what is a server? So what does the server contain? The servers are nothing but machines. They are systems, computers. Okay, they are computers with a high processing capability and high storage capability. Okay, they are they are also having combination of many softwares for accepting these requests from the for processing the request and also the responses. Okay, so whatever request that is getting from a client need to be processed. Okay, and it's given to this particular servers. The server will again process it and take the needed requirement and give the response to the particular client. For that, all those things we require certain software which is installed in these servers. Okay, so this is called a basic client server architecture. Okay, so we have studied centralized architecture. The second one is basic client server architecture. Now next one is two-tier client server architecture. So multiple clients are connected to a database server. So here the mechanism is that here we are having only a database server, DBMS server. Okay, so this is one client. Similar to this, we are having similarly we will be having multiple clients. So each client will be having a particular application program. This is the client application program. This client application program will do the necessary processing, and the request will be transferred to the DBMS server. Okay, so this server is called database server or DBMS server. Clear? So that is what it is saying, that multiple clients are connected to a database server. Okay, so this user is having an application program. This client will be having an application program that will be running all the queries, or it will be running processing all the requests as well as responses. Okay, clear? Then if a request is if a client is accessing if client is trying to access a particular database or particular data, he wants a particular data, so that query will be pre-processed by this application. It will be given to the database server. In the database server, they will be having some specialized softwares. That specialized softwares will be processing this query and give the response. Okay, so this is the actual figure for the two-tier client server architecture. Why it is saying two-tier? Because two-tier means two levels. Here we are having first level and second level. The first level is client. Okay, second level is database server. The client contains client contains one more client application. Okay, client one more component is there, client application, which will be integrated in the client. Okay, so two levels, that is why it is called two-tier architecture. Okay, let us see the explanation. Multiple clients are connected to a database server. Okay, multiple clients are connected to a database server. The user interface programs and application programs can run on the client side. Okay, the user interface programs, all the user interface programs and the application programs are run in the client side. Okay, the query provided in the client side is processed by the database server. If an application, the user is client is giving a certain query for what do you mean by query? Query means we requesting command for accessing a particular document, a particular data from the database. Suppose the client wants to retrieve the name of the students in SPOCAC. That is a query. Okay, so that query can be processed by the database server. It is having specialized software. When query provided on the client side is processed by the database server, when the DBMS access is required, the program establishes a connection to the DBMS. Okay, so that is another point. So if we want to access, if a client needs to access to a database server, it requires certain connection. Connection has to be established between the client as well as the database server. Okay, for that purpose, we require certain standards. Okay, for getting a connection connection with the client and the server, we require certain standard. That standard is called as open database connectivity. That is what we are going to see in the next slide. A standard called open database connectivity allows the client side program to communicate with the DBMS. So ODBC or open database connectivity is a standard that allows the client to communicate with the database server. Okay, so that is a very important point, how a client communicate with the database server using a open database connectivity, ODBC. Okay, so most DBMS vendors provide these ODBC drivers for their system. So most vendors, actually the DBMS vendors are actually providing this ODBC driver. Okay, the DBMS, the creators of the DBMS are actually making these ODBC drivers, and they are providing these ODBC drivers installed in the client. Okay, so this architecture is called two-tier because the software components are distributed over two systems, client and server. Okay, so why it is called a two-tier? Because the components, the software as well as hardware components are distributed over the two systems, client and server. Okay, client and server. So here the server name is database server or DBMS server. Clear? So this is a two-tier architecture. Now let us see the final one, three-tier and n-tier architecture. Okay, so let us see the figure. So this is the three-tier or n-tier architecture. This is the three-tier architecture. So why it is called 3-tier? Can you differentiate between the 2-tier and 3-tier? This is 2-tier, okay, and this is 3-tier. So in addition, we have another one thing here, which is called application server. Okay, so we are having a specialized application server inside the DBMS server. Okay, so for additional data processing and additional capabilities, they have integrated another application server. Okay, or application server is also integrated here. Okay, so the client is having their own application, and the DBMS is also having a separate application server. So this application server will be acting as a middleware or a intermediate layer. So whatever request we are getting from the client will be processed by this application server or this intermediate layer or middle layer. So why they have implemented this application server? Suppose if they want to give certain authorization, or if they want to give some authorization to a particular user, that is, if a client is trying to access a DBMS server, okay, and the client can access the DBMS server by giving his credentials. Credentials means user ID and password. So those credential processing is done by this application server. Okay, so the credential, whatever credentials that is giving, that credentials need to be matched with the original credentials that is given using registration purpose. Okay, and all those matching and all those interfaces are done in the application server. That is one example. Okay, another example is if a application or if a user in business oriented transaction and all, there will be certain rules provided. Okay, so those rules can be implemented in the application server. Okay, for example, if a database in a bank database, okay, in a SBI bank database, there will be separate credentials for user as well as the bank personnel. Why? Because bank personnel will be having some more many additional features they can access, but users can view only limited features. Okay, so all those business rules or all those constraints or all those rules are actually given in the application server. Okay, so that is called a 3-tier architecture, and in comparing with the 2-tier, they are having a separate, additionally they are having a separate component called application server in the DBMS server, integrated in the DBMS server. That is why it is called 3-tier. It is having 3 levels: first level, second level, and third level. That is why 3-tier. Okay, so this application server is the intermediary, or it is acting as a middle tier between the client and the DBMS server. Okay, let us go through the explanation. It adds an intermediate layer between the client and the database server. Clear? It is an intermediate layer between client and the database server, between the client and the database server. Okay, this intermediate layer or the middle tier is called application server or web server, depending on the application. So this is called application server or web server. Web server plays an intermediate role by running application programs and storing business rules. It will be running various application programs as well as business rules. What do you mean by business rules? Procedures or constraints. As I said, the procedures or the constraints that are used to access the data from the database. Okay, we can give certain constraints such that only the administrator or only the bank managers can view the bank statements of different users. We can give certain constraints. So all those constraints are given in the application server. Okay, it can also improve the database security. Okay, can also improve the database security. How? By checking the client's credential before forwarding the request to the database server. Okay, the client credentials. If a client want to access the database, they can provide a credential requirement. They can only after matching the user ID and password, the client will be given the access to the database. Okay, such security can be given here. Okay. So client contains GUI interfaces and some additional application specific business rule. So what does client contain? The client contains various graphical user interfaces, okay, and some application specific programs are also there. Now application server accepts requests from the client, process the request and sends the database queries and commands to the database server. The response from the database is partially processed by the database server, which is passed to the client, where it may be processed further and filtered to be presented to the users in the GUI format, which means that the database request from the client will be reaching this application server. So this application server, what does it do? The application server will accept these requests, okay, from this client, and they will process it. Okay, why they are processing it? Because they have to convert it to the format that is understandable to the DBMS. So application server will process those information and convert that converted query will be given to the DBMS. Now DBMS will give the response, take the response and give back to the application server. Okay, so DBMS will take the response and give back to the application server. That application server again partially process it. Okay, why partially processing? In order to convert it to the format that is acceptable to the client. Okay, client application. So this application server will partially process those response in the format that is acceptable to the application that is given in the client. Okay, and those response received from this application server will be again processed and given to the user in the required GUI format, graphical user interface format. Okay, so this is the process that is explained here. Clear? Okay, in simple words you can explain in this manner. Okay, so these are the main architectures. We have seen in the database. So this is a very important topic. Okay, mostly any one architecture they will specify and ask in the university question. Okay, so we are having 4 different architectures: centralized, basic client server, 2-tier and 3-tier entire architectures. Okay, thank you.